Greetings to one and all. I am Joel Silas, and in our previous session, we had seen the following topics. Firstly, we had seen what is programming. Then we saw what is machine learning and the difference between programming and machine learning. Then what is the difference between AI, ML, and DL, that is artificial intelligence, machine learning, and deep learning. Then the workflow of the machine learning algorithms or machine learning process. Then the steps that are involved in order to deploy a machine learning project. And finally, classification of data, which was structured, unstructured, semi-structured, or one more classification is between quantitative and qualitative. So now let us go to the next topic, which is types of data analytics. First one is descriptive. In descriptive analytics, it answers the questions such as about the events which have already occurred. Usually raw data is queried about without adding any information. This is the simplest form of analytics. It answers questions like how many items or how many patients suffered from particular disease or how many calls did you receive for this issue. It is usually done using a database of queries and using spreadsheet filters, and periodic dashboards and reports could be generated. So mainly it describes the events, like what happened, how it happened, and so on. Next is diagnostic. In case of diagnostic analytics, it is done in order to find out the cause of the phenomena or to derive the reason behind a particular event. It is used to fix a particular situation or event. Diagnostic analytics usually adds more context to the data to get information about a particular interest. For example, the questions that can be answered are like why the sales in the second half is less than those in the first half, or why people are falling ill, or why this particular model of the car is more preferred over that particular model. That means it answers the question why. It diagnoses the reasons. Next is predictive analysis. In predictive analysis is carried out to predict or forecast the future possibilities. The information is enriched further to derive knowledge. They are created in order to determine the future and make arrangements accordingly. So it can answer the questions like what can be improved in this particular composition of the medicine, or which team will likely win the World Cup this year. That means what will happen. It deals with the future. Next is prescriptive analytics. It takes the results from predictive analysis and adds further human judgment. So it prescribes or it suggests or it recommends what can be done further in order to allow a situation or in order to restrict a particular situation. For example, what should you do to delay the cancer, or what is the best time to leave home for this particular route? Which medicine has higher chances to cure the patient? So based on the particular condition of the patient, we can recommend the medication. So it is mainly suggestions based on the predictions. Prescriptive analytics is most difficult out of all analytics since it requires so much of data and so much of expertise and skills, evaluation parameters, and so many other things determine it. Okay, so in case we want to understand the complexity of these analytics, that is descriptive, what happened, diagnostic, why it happened, predictive, what will happen, and prescriptive makes the arrangements or suggests something. To understand the severity of these types of data analytics, we can consider a particular graph. For example, first of all, we will have the descriptive analytics. Then a little higher will be the diagnostic analytics. Even more higher would be predictive analytics. And finally, prescriptive analytics. And the transition from descriptive to diagnostic, this can be called as hindsight. The transition between diagnostic to predictive, it can be called as insight. We are gaining certain insights from the diagnosis in order to perform the predictions. And finally, the journey from predictive to prescriptive can be considered as foresight. And we can say that this is least complex. And in comparison, this is most complex. So these are the types of diagnostic analysis. These are the types of analysis. Now, next, we can come to the types of machine learning. Broadly, there are three types, that is supervised, unsupervised, and reinforcement. So what is supervised machine learning? In case of supervised machine learning, we have a particular input section, we have a particular output section, and in between there is some processing. Now, this is the input. And here we have some apples as the input data items. All are apples. Here you can see a particular supervisor, or you can say teacher or trainer. This teacher will supervise the model building. It will help in the training of the algorithm. So whatever training data set we have, training data set means a pair of input and output. Training examples. So in the training data set, we'll give certain inputs, and mapped to these inputs are certain desired outputs. Based on this input and output, what the algorithm will do? In the previous lecture, we understood that the algorithm is nothing but the mapping function in case of supervised machine learning algorithms. Now, this algorithm has the input, which are these two, right? These two. Input and output pair is given as input for the algorithm. This is known as labeled data. Why labeled data? Because whatever input data items are there, whatever it may be, we are attaching a tag to it called as apple. That means what it is, or we can say what is the output of this. Output is what basically we want to predict that whether the new input is also an apple or not. So it is a kind of classification that we are doing. That means once we train using these inputs, whatever new input, if it is also an apple, the prediction should be an apple. If it is not an apple, prediction should be not an apple. Okay, so based on the algorithm, the prediction should be done that whether the input next which is given is an apple or not. So we are attaching the tags. That means tags, nothing but labels. That means nothing but the actual output. We want to predict whether it is apple or not. So that output we are attaching with the data items for each and every data item. So when we attach it, we are labeling the input data. So it is called as labeled data, which is fed to the machine learning development algorithm. This machine learning algorithm will be trained, model will be trained. That means it will learn that if this is the image, then it is an apple. It will learn by these training examples. Okay. And it will do the processing. It will get trained. Now, suppose we give another image. This may be an apple or it may not be an apple. Suppose this is an apple. The output of the machine learning algorithm should be that it is an apple. If this is not an apple, output should be not apple. Now, in this case, do not only consider the color of the apple. Here in the input, the color of the apple is all red. But the machine learning model may also be trained based on the shape. Shape is what? Something like this. And now the new image that is given at the input also has the same shape. So it will be able to decide that, yes, it is an apple. If the machine learning model is developed properly, it will say it is an apple. Suppose only color would have been considered as a feature to determine whether the output is an apple or not. Then what would happen? Color is different. It would say it is not an apple. Whereas in reality, it is actually an apple. Okay. That is why we need to keep on improving the performance, the accuracy, the experience of the model. So in supervised machine learning, what did we learn? We learned that there is a particular supervisor or teacher or trainer in which he or she will supervise it. For example, the supervisor, the teacher is nothing but the input data set only, the raw data set. The input data set, which consists of training and testing. So we have the particular training data set. Which consists of pairs of input and output. And we have a particular testing data set. Now, these two data sets doesn't mean that they are too different. What we have done actually is we have a big data set which consists of inputs and output pairs. And this particular data set, if it is consisting of 100% of values, we may split this whole data set into, say, 30% for training, and maybe 70% for testing. Or we may go for 70% for training and 30% for testing. So these input-output pairs, which are there in this data set, they will be divided here and here. Now, what we'll do there is, for training, we will use these pairs. The model will be trained. And after training, what we'll do? We'll give this input for testing. We will give this input to the ML model. And this ML model will generate some output. Say this output is Y dash. Now, this actual output that we had in the test data set, let us say it is Y. Now, only if the prediction, what is the prediction? Y dash is the prediction. If Y dash and the actual output Y, if both are same, means what? Prediction is correct. And the accuracy, that means how many times the prediction comes correct. How many times the prediction comes correct will determine the accuracy of the model. Okay, so only if Y dash is equal to Y, we can say that prediction is correct. But if Y dash is not equal to Y, we have to say that prediction is wrong. Right, simple. So mainly we have data set, we'll split it into training and testing. Then we'll train based on input-output pairs of training data set, and we will test using the input of testing data set. If predicted and actual output are same, that means accuracy is established. Now, how to improve the accuracy, one thing is it depends on the data set. If you go to see, if the data set has a good combination of all the particular features and outputs, for example, we have an image and the output of this is means the tag, the label is Apple. Like this, if we have say 98 images and only 2 images which are not Apple, do you think that the training will be done well? No, because there are just 2 images for the model to learn that they are not Apple. And there are so many images in which the model learns that yes, it is Apple. So you're not giving a good chance for the model to learn that it is not an Apple. You're giving only 2 examples, right? So a good combination of all kinds of possibilities of the input-output pairs must be given, right? Another example of learning by experience is, suppose your teacher gives you the task to find out the time given the speed and the distance. Just a minute. So suppose your teacher has given you the formula speed is equal to distance upon time. Given the value of speed, say 70 kilometers per hour, and given the value of distance, say 30 kilometers, find the time. So this is one example that they've given, the teacher has given, or the data set has given. Another example, same formula, different values of speed and distance, you can find out time. Third example, different values of speed distance, you can find time. Now, if all the examples are like this, and suddenly you get an example where the task is that given the values of distance and time, find out the speed. Till now, what you have been doing, you have been finding out time. But suddenly, without training, if you have been asked that, find out the speed, then will a person or will the machine be able to do that? No, he needs training that if distance and time are given, yes, I can find speed. So it depends on the type of training that you give, which determines your performance. Next is unsupervised learning. Unsupervised learning. Now, in unsupervised learning, we do not have labeled data. We do not have labeled data. Okay, before going to unsupervised, let us see. Okay, this is an example of supervised learning. Another example, okay. So, this is supervised learning example. Now, here you can see different kinds of images or characters. A duck, another type of duck image, not a duck image, not a duck image, not a duck image, another type of duck image. Now, the training should be such that given these are ducks, you are able to identify that a new data input, this one is also a duck, should be the prediction. Right? So these are the labels attached with the inputs. Based on this, the model will learn. New image is given, model should be able to predict that whether it is a duck or it is not a duck. So these are 2 classes or 2 categories, duck, not duck. Okay, this is supervised. These are certain supervised learning algorithms There are two categories mainly of supervised learning. So in supervised learning, we have two categories, that is regression and classification. So we'll be studying this in detail. However, in regression, we have something called as linear regression algorithm, then something called as random forest for regression as well as classification. Then there's something called as support vector machine. These will be done in further sessions. Some more examples. The speech assistance that we get on our mobile phones, like you can talk and based on what you're saying, it will understand whether it is your voice or not, and then it will respond. Such applications are possible. Based on the weather conditions. Suppose Monday, Tuesday, Wednesday, it has been raining. Then whether it will rain on Thursday or not. Or maybe alternate days are, it is such that it is sunny on Monday, cloudy on Tuesday, sunny on Wednesday, cloudy on Thursday. Then what will be the next possibility? So based on the previous history or examples, what will be the future? This is the prediction. Also, fingerprint recognition. We all have unique fingerprints. So we register our fingerprint. It will decide whether it is that same person or not. Classified. Then another example is predict credit worthiness of credit card holders. That means the credit card that we are using or the person who is using the credit card, is he genuine or not? Based on the number of times transactions are done per day or number of incorrect password attempts and so on, predictions can be done. These are advanced machine learning projects. Prediction of patient readiness rates, how well the patient will respond to the particular medication, what is the percentage of his response. Okay. Then analyze the products the customers buy. Okay, let us come to unsupervised machine learning now. In unsupervised machine learning, we again have some input section and again some output section. Now, in the input, we do not have labels if you see. We just have the input data items. Now, these inputs may be of the same type or maybe of different type. For example, here we have apples, we have bananas, and here we have mangoes. This we know by seeing because we are human beings. How will the machine understand? We have not even told that which image means what. In such a case, what will happen is we expect the machine to identify patterns, to identify features, to identify characteristics, to identify similarities between the images. Similar, these two are similar, these two are similar. Identify similarities and create collections of all similar images. Create clusters of all similar images, right? We are expecting the machine to itself learn based on similarities between the inputs. I hope this is clear. So output is unknown. There is no training data set given. I mean, the data set does not consist of input-output pairs this time. Input-output pairs are absent. What is present? Only input pair is present. Output pair is not. Output section is not present. Label is not present. Only input is present. So what the model will have to do is, based on the inputs provided, only inputs are provided, it has to interpret, it has to identify patterns. And it will develop the algorithm which will identify the patterns, develops the algorithm will perform the processing. And finally, what you'll get in the output? You will get the different categories, different classes, which the machine has discovered on its own without prior training. That means it is like an intelligent student. Previously, in supervised, what we had not so intelligent students, wherein particular training had to be provided to them. But here, this is an intelligent student. No much training has to be provided. Only give the input, rest everything the student will do. That means rest everything the unsupervised machine learning model will do. So the model that is trained, we have the groups like apple, banana, and mango, separate. So these are the three classes, three categories that are possible for this particular input data set. Now, this particular unsupervised approach is called as clustering. This is actually a clustering algorithm. We'll see this later on, how this algorithm works in detail. Now, for the same example, let us ignore the labels. In supervised, what we had duck over here. We had duck over here, not duck over here, and on. But here we don't have those. There are no labels provided. Labels are absent. That means you can understand that this is an unsupervised approach that needs to be implemented for this particular data set. Now, in unsupervised, what will happen? It will try to identify characteristics. So maybe the beak, all these images have beaks. So maybe all these are belonging to the same category. This is how it can decide. So there are different parameters based on which the model has to identify characteristics. Then on applying new images, also it should work. First of all, on the input that is given, on this itself has to work and give the categories, all ducks and not ducks. Here, there are more classes actually. These are ducks. These are rabbits. And these are said dogs or wolves or whatever this image is. So not necessary there are two groups only. Previously, what we have seen in classification also, we have seen example of two groups. Okay. Now, just another example that I would like to add for classification. In classification, not necessary that we have to classify that whether the apples are sweet or not. What is the prediction for this particular example? A classification example let me give and compare it with clustering. Okay. This is what supervised machine learning algorithm. And we have clustering. This is just an overview that we are discussing. Later on in detail, we will discuss each algorithm. And this is unsupervised machine learning algorithm. Now the problem statement for classification can be three kinds of images are given. And we have to determine, and labels are also given since it is classification. This is a square, this is a triangle, this is a circle. This is the input data set. Based on this, if a new image is given, for example, what can be the new image? Maybe an inverted triangle, but this also has three vertices. So it is a triangle. You can classify that way. So based on the new data that is given, we can predict there are three possibilities. What are the three possibilities for this particular image? We know that the machine learning model knows that this can be either a square only, or it can be a triangle only, or it can be a circle only. And it will map this image to triangle. So not necessarily there are only two classes like human being or animal. Fingerprint match, fingerprint not match. No, not necessary. There can be more than two classes also. For example, this example. Now in clustering, what will happen is the main idea is without labels, the data is given. So in clustering, what will happen? Only the data inputs will be given. The machine learning model does not know which is square, triangle, and circle. But based on the characteristics, it has to decide that which is a square, which is a triangle, and which is a circle. So it will decide based on the number of vertices or whatever it is. So it will decide and it will form different group of all squares, different group of all triangles, different group of all circles. Right? So this is how it will classify. So here, categories or groups are three, maybe two, maybe four, or how many of them. Now, unsupervised machine learning algorithms can include examples like this one. A priori algorithm, k-means clustering algorithm, hierarchical clustering, and so many others. Now, another thing apart from clustering in unsupervised is unsupervised ML can also consider, we can consider the situation of association. This is an example of association in which maybe we want to find out, the shop owner wants to find out that which products are bought together. That means this is actually a famous market basket analysis. So in market basket analysis, what needs to be done is we need to find out the groups of items that are bought together so that if you have noticed in supermarkets or malls, mainly the things that are usually bought together are placed in the vicinity of each other. For example, if this is the mall, then over here you'll find bread. Somewhere nearby only you will find milk, because people usually buy bread and milk together. Or maybe just alongside you will find jam also, bread and jam. So this is how the items are arranged in the markets based on association rules between the products. So that person wants to buy only bread, his sight will fall on the jam as well. He'll buy the jam also. Okay. Another thing can be maybe two products, bread and butter, are kept together. They are associated with each other. And there is a discount offer given on eggs. Maybe the customer will spend a little more and buy bread, butter, eggs together. This is how you can increase the sale, right? This is another aspect in unsupervised learning. Also, if we are considering another example of unsupervised, grouping of customers based on their behaviors. Now, why is this important? Because based on the behavior of the customer, we can find out the different kinds of behaviors, and accordingly, we can suggest them products, or we can suggest them the movie recommendations or shopping items that they may like, and so on. Categorizing MRI data by normal or abnormal. We do not know the different types of diseases in MRI, suppose the different kinds of images that show diseases in MRI scans. So cluster them based on similarities. This is an example. Then recommendation of products that we just now saw based on past purchases also, or experience. Now next is reinforcement machine learning. Reinforcement means reinforcement machine learning we'll see in the next lecture. So in today's lecture, what we mainly discussed were the types of data, that means analytics, data analytics, that means descriptive, diagnostic, prescriptive, and predictive. Then we saw two types of machine learning broadly, that is supervised and unsupervised. In supervised, we saw what are the possibilities, why it is necessary, then how is it different from unsupervised, examples of clustering, association, classification, and so on. The next lecture we'll see reinforcement learning, which is even more advanced topic in which research is still going on. So thank you for giving me a patient listening. We'll continue in the next lecture.